Good day, stats students. We're going to start our video lectures today. Mind on Statistics is our textbook, and obviously we'll start with Chapter 1. And so, let me get my pen out. There we go. And Chapter 1, the text goes over a bunch of real life scenarios, and you can read through those. I'm not going to go through them in the video lecture, okay? But the main point that they're trying to get to is, what is the study of statistics? And so the study of statistics, I'll give you the textbook definition, then I'll make it a little simpler. It's a collection of procedures and principles for gathering data and analyzing information to help people make decisions when faced with uncertainty. Okay, so in other words, we're using data to solve real world problems. And so that's really what it comes down to, is that we're going to try to use our data, okay, and in the real world we have a bunch of uncertainty, okay, and so somehow we're going to have to uh, gather up this data, analyze this data, and apply it to the problems that we really have in the real world, okay. So that's really what we're talking about with statistics, okay. So you can read through those scenarios, and once you get the gist, great, you can move on. But that's really what Chapter 1 is about. Really what I want to get into more is about Chapter 2, okay? And so I've created, what I've done is I broke this down into the different sections, okay? Because there's a lot to Chapter 2. Nothing real hard, but there's just a lot of information, okay? So I broke it down into sections. And so the first thing that we should talk about is raw data. What exactly is raw data? Well, let me give you an example here. So if someone recorded for UA students whether each student was an undergrad or graduate, the following would be the raw data maybe. So we would have a bunch of U's and G's, U standing for undergraduate, G for graduate, okay? And so obviously we would have a lot more undergraduates than graduates, okay? And this would be the first person right here. This would be the second person. This would be the third person. This would be the fourth, and so on and so forth. That's what we mean by the raw data. Well, maybe then we would record their age in years. Okay, so maybe we would have something like this, that we have at 18, 19, 23, and so this undergraduate person would line up with 18. This undergraduate would line up with that number of 19, graduate of 23, and so on and so forth. Okay? And so that's what we're talking about, raw data. So we would have what we call variables here, okay, whether they're undergraduate and graduate, and then we would have the data, okay, the raw data, if you will, okay, and we would do this by person, okay, and we would have probably several variables, not just one or two, but probably several. All right, so what we're going to find out here in section 2.1, especially in the beginning here, is that there's a lot of definitions to go over, and so just kind of bear with me. So we have what's called a population. So this is a collection of all individuals, things, or outcomes as defined by the researcher. So there's a couple of things that I want to point out to you. The first thing is the end part here, defined by a researcher. So the way I'm going to approach this course is that we're a researcher, and so we're going to have various things to research later on in the semester, and so that's the approach that I take, is that from that angle, okay, that we're a researcher, we need to solve this problem, and here's the data to solve that problem. How can we solve it? Okay, and so that's the first thing. Okay, so the population isn't just set in stone right from the beginning, okay, that everybody, all researchers use the same population. No, it's actually defined by the researcher. So the researcher might be just interested in people who have colon cancer, okay, and so or a researcher might be concerned about all first graders for some reason. Okay, it's just how whatever the researcher is interested in learning about. Okay, and like this says, it's going to be individuals, it's going to be things, big outcomes. All right. Now, one thing that I do want to point out to you guys is that to understand when we're working with the population, probably one of the smaller words in this definition is really important, and that's the word all. Okay, so if you see a problem in the textbook or exam or whatever, and it says, hey, we're looking at all these people or all these things. What the textbook is trying to convey to you is that you're working with the population at that point. Okay, so that's kind of an important word to pay attention to when you're reading through these examples and problems and so on and so forth. Okay, so here's the problem. Here's a problem: is that often a researcher cannot gather the information for the entire population. Okay, why? Well, one reason is because maybe the researchers just can't do it. Okay, um, why can't he or she do it? Well, maybe this researcher lives in the United States, okay, but part of his population is all spread out all over the world, okay. Now in these day and age, maybe it's a little bit easier to contact those people, but you're going to contact, if you're researching colon cancer, are you going to find out everybody in Africa and everybody in Australia and everybody in Europe and so on and so forth that has colon cancer? No. Okay, that's impractical. And by the time you did that, you've wasted so much time doing that. Where and you waste a lot of time, a lot of effort, a lot of money, and the population is probably shifted at that point. And what I mean by that is that what's going to happen during that time? Some people are going to die. Some people are going to uh, uh, get colon cancer and so on and so forth. So it's shifting. Okay, so it's very impractical as a researcher to try to get the entire population. By the way, I want to bring this up. What's the word that we would use when we look at the entire population? Everybody knows this. We do this every 10 years in the United States. Hopefully, most of you said, yeah, it's a census. Okay, so when you take a census, you are looking at the entire population. Okay, so rarely does a researcher take a census. Okay, it takes too much time, too much money, uh, and things have just shifted. Okay, if you try to gather up all that information. Okay, so what are we going to do instead? Well, we're going to probably take a sample, actually a random sample, but we'll talk about randomness later. So what's a sample? It's a subset of a population from which data about a population is obtained. Now, here's the thing. So notice that it's about the population. The whole reason why you went ahead, or a researcher went ahead and took a sample, is because they're trying to learn about the population. That is easy to forget as we go through this course. Okay, the whole reason why we took the sample isn't just to learn about the sample. We're actually trying to learn about what? The entire population. Okay, so keep that in mind as we go through the class. Okay. Oh, a subset. So it's a portion of the population. Okay, and so I'm sorry if I skipped over that, but it's a portion of the population. Okay, so the population might be this all these people. Okay, like in here, but we're not going to look at all of them. All right, what are we going to do? Maybe we're going to randomly pick this person and that person and this person and so on and so forth, and we bring them over. Okay, into the smaller group, and that would be the sample. Okay, and that would be the sample, much smaller than the actual population, so it's a subset. Okay, here's an example. So we randomly asked 250 UA students, what is your favorite flavor of ice cream? So something real simple, okay? 63% answered chocolate. Okay. So first question, did we take a census? Did we take a census? No, right? Because we have a lot more than 250 UA students, right? And so we did not take a census, all right? So what did we do? We took a sample, right? So what is a sample? So let's define the sample in terms of the problem, okay? So I'm not asking for a definition. I'm saying, hey, what is a sample based upon this problem right here? And so hopefully you would have answered, well, the sample is the 250 UA students that we went ahead and asked, okay? So the sample should have a finite number to it, okay? In this case, the 250 people, all right? And then there should be some sort of description after that, okay? And in other words, we have we took a look at UA students. Don't just say that our sample is 250. that's not good enough. Okay, if I ask this question on the exam, okay, um, and you put 250, I would put, well, did we ask 250 kindergartners, first graders, 250 Americans age 60 years or older? No. Okay, so we need a description to it. Okay, as far as what the sample is. Question 3: what is the population? And that would be, oh, all UA students, right? All UA students. So if you put the word all in there, okay, that tells me that you know what's going on. Okay, and a lot of times what you could do is you can take this number right here that you started with the sample and replace it with the word all, and that probably is going to work 99.9999% of the time. Okay, going from the sample to the population. Now in the real world, okay, if we're doing a real world problem, probably what would happen is kind of exactly the opposite. The researcher would define the population and then figure out the sample and what we call the sample size, how many people or how many things to go ahead and actually sample. But in this problem, you kind of have to do it in reverse, okay? You have to figure out what the sample is and then go back to the population. Okay, let's stick with this problem right here, okay? The textbook then mentioned statistics, okay? And what is a statistic? So within the study of statistics, we actually have the word statistics, okay? And so statistic within the study of statistics means a measurement that comes from a sample, all right? So in this problem right here, the 63% would be a statistic. Why? We took a sample, all right? We took a sample, right? And we got some sort of measurement from it. Here, the 63% that said chocolate. Okay, so the 63% would be a statistic. What's a parameter? Well, that's a measurement from a population. Now, here's the good thing, is that how can we keep these straight, meaning statistics and parameters? Well, notice statistics start with an S, sample starts with an S. Parameters start with a P, population starts with a P. So you can kind of keep them straight, okay, by using that simple little method right there, okay? So stats come from samples, parameters come from populations. Here, we would have to infer something about the population, about that parameter, okay? So here, the actual parameter would be the percentage of all UA students that answered chocolate, okay? But do you really think that we're going to ask all UA students their ice cream preference? Probably not, right? Excuse me, probably not. So, we have something to learn here, okay? We will try and learn about parameters, but not by taking a census. So how are we going to learn about these parameters? We will learn about parameters by their corresponding statistics. And so in other words, we have what we call a population proportion or population percentage that we want to learn about, but we're unwilling to take a census. So what are we going to do? We're going to take that random sample, we're going to calculate the corresponding statistic, and use that statistic somehow later in the semester to figure out something about that corresponding parameter. Okay? And that's basically what I said there. In our example, we'll eventually infer something about the ice cream preference of all UA students, the population, by using the information obtained from the sample. So in other words, excuse me, we're going to infer something about the population by using the information obtained from the sample. That's why you guys are here, essentially. If you have to take Intro 2, that's what we're going to learn, is how to bridge the gap between populations and samples, and we're going to infer something about the population, meaning a parameter, by using the information from the sample, meaning statistics. So we use statistics to understand parameters. We use our samples to understand our populations. Okay, and that's what Intro 2 is all about. Okay, so that's the end of this section. Thank you for your time.